Have you ever gazed at the night sky, only to see stars flickering like they're in a celestial dance-off? It's a beautiful sight, one that poets love and scientists can explain. But here's a fun fact to start with. Stars don't actually twinkle. Yup, they're not teasing you with their blinking, it's all an illusion, thanks to Earth's wobbly, windy, and ever-changing atmosphere. Buckle up, because we are diving into the twinkly tale of stars, light, and a whole lot of atmospheric science, with a sprinkle of humor to keep things bright. Refraction, the wibbly-wobbly way of light. Let's start with a physics party trick, refraction. It's what happens when light passes from one medium to another, say, from the vacuum of space into Earth's turbulent atmosphere. The light bends like it's doing yoga. Why? Because the speed of light changes in different materials. Imagine driving on a smooth highway, space, then hitting a muddy, bumpy road, our atmosphere. Your car, or light ray, swerves. That's refraction. And Earth's atmosphere isn't just one neat layer. Oh no, it's a crazy lasagna of air pockets, all with different temperatures and densities, stirred up by winds and weather. When starlight travels through this lasagna, it bends repeatedly in different directions. The result? It looks like the star is jiggling. Add in the fact that the atmosphere never sits still like a toddler after a candy binge, and you have got starlight doing the cha-cha. It's a cosmic prank that nature plays on your eyes. You think stars are flickering, but really, it's just light getting dizzy. Good luck blaming the star for that sparkle. Light's wild journey to your eye. Picture this. A beam of starlight has traveled billions of miles unchanged, untamed, and perfectly straight. Then bam! It hits our atmosphere and goes on a turbulent roller coaster ride, zigzagging all the way down to your eyeball. Because the atmosphere is constantly shifting, the starlight doesn't bend the same way every second. Some of it bends toward you, some away from you. The result is a flicker. We call it scintillation, a fancy term for twinkling. And here's the kicker. This twinkling happens so fast and frequently that our brain just perceives it as a star winking at us. Romantic? Sure. Scientifically, it's all about physics and moving air. So while you are staring up thinking the universe is flirting with you, it's really like playing pinball through air currents. That star isn't winking, it's just exhausted from all the zigzagging. If it had eyes, it'd be dizzy too. Space may be silent, but Earth's atmosphere sure knows how to throw a rave for photons. Why twinkling is worse near the horizon. Have you noticed stars near the horizon twinkle like they've had 3 espressos, while those overhead are relatively chill? That's because starlight passing through the horizon has to travel through a thicker slice of the atmosphere, kind of like going through 10 filters instead of 1. More layers, more refraction, more wiggles. Hence, stars near the horizon look like they're having a sparkle attack. Overhead stars, they just took the express lane. Think of it this way. Overhead stars take a quick, clean elevator ride. Horizon stars? They're stuck in the stairwell during a fire drill. The poor light beams bounce around so much, it's a miracle they reach us at all. Honestly, they deserve applause just for making it to your eyes. Someone give those horizon stars a participation trophy. But planets don't twinkle. Are they special? Let's put it bluntly. Planets don't twinkle because they're chonkier. Scientifically speaking, planets are much closer to Earth than stars. While stars appear as infinitely small point sources of light, planets appear as tiny disks, though still small to the naked eye. So instead of one ray of light flickering at us, a planet sends many tiny beams. If some rays get distorted by the atmosphere, others compensate. The net result, the twinkling cancels out. Planets look like stable, calm lights, like that one friend who's chill at every party. They are basically the Zen masters of the night sky, no sparkle drama, just steady glowing vibes. It's like comparing a disco ball, stars, to a mood lamp, planets. The universe really said, let stars party, let planets parent. And honestly, we love them both for it. Still curious? Let's give the science one last hurrah, this time with extra flavor. Refraction happens when light travels through layers of air that have different temperatures and densities, causing it to bend. It's basic physics, sure, but the way it plays out in the atmosphere is anything but boring. Our atmosphere is basically a chaotic lava lamp in the sky, constantly shifting, bubbling, and throwing starlight off course. As the light from distant stars enters this wild ride, it refracts again and again, sometimes toward your eye, sometimes away from it. This chaotic dance creates the illusion of twinkling. The farther the star, the more zigzags it endures, which makes the twinkle even more pronounced. Closer celestial neighbors like planets don't suffer the same fate, since they appear larger and send multiple light paths to your eyes. Some get distorted, but others don't, and they balance each other out. So if stars could talk, they'd probably sigh and say, "Hey, don't blame the twinkle on me, it's your planet's fault." The more you know about stars. Before we wrap things up, here are a few cosmic goodies to stash in your brain's trivia folder. First off, the fancy scientific name for twinkling is stellar scintillation, because even science likes to sound posh. And yes, you can actually reduce twinkling if you use a telescope from a high-altitude location. That's why astronomers love setting up their gear on mountaintops, far away from all the atmospheric drama below. Even cooler, astronauts in space don't see stars twinkle at all. Without an atmosphere to mess things up, starlight reaches them unfiltered, pure, steady, and breathtaking. In other words, Earth is like the Instagram of the solar system, slapping filters on everything whether we ask for them or not. It's kind of like putting glitter on a masterpiece. Flashy, yes, but not exactly true to the original. Frequently wondered weirdness. Let's be honest, when stars start blinking at us, we naturally have questions. One of the most common, when exactly do stars twinkle? Well, only at night, when the sky is dark enough for them to show off, and only when viewed from Earth's surface. That's right, you need darkness and atmosphere for the magic to happen. How fast do they twinkle? Incredibly fast, fractions of a second. It's happening quicker than you can say Sirius is serious, which is both a pun and a fact. And no, the moon and the sun don't get in on the twinkling action. They're much closer to us and appear way larger in the sky. So even though their light passes through the same atmosphere, it doesn't get scattered the same way. Plus, let's face it, if the sun started twinkling like a disco ball, we'd all be a lot more concerned than amused. So while stars are playing the role of atmospheric puppets, the moon and sun are just out here keeping it steady and reliable, like the universe's version of the responsible older siblings. What else can you learn? If your curiosity is still doing backflips, don't worry, there's a whole cosmos of cool stuff waiting. For starters, check out the life cycle of a star, where stars go from fluffy baby clouds to explosive old age with way more drama than a soap opera. Then there's constellations, which are basically ancient connect-the-dots turned sky legends. You'll never look at Orion the same way again. Want to get extra nerdy? Dive into variable stars. These are the emotional ones that actually do change brightness, but not because of twinkling. Nope, they've got internal processes and cycles going on. Basically, they're the introverts of the cosmos with complex personalities. So if you're looking to impress friends, ace a quiz, or just sound cooler on a stargazing date, these are your go-to topics. Because nothing says romantic like whispering, "Hey, did you know Betelgeuse might go supernova someday?" If you loved unraveling the mystery of twinkling stars, don't forget to give this video a big thumbs up. Got questions or cosmic thoughts? Drop them in the comments. We'd love to hear from you. For more fun, fascinating space facts, make sure to subscribe and ring that notification bell. Until next time, keep looking up and stay curious, stargazers.